Hi, this is Mrs. Secor, and today we're going to study about polygons other than the triangle. First of all, it's just mainly about vocabulary. Let's look at this page, if you can find it in your notebook. Just 3 pages today. An equilateral polygon has all sides congruent, and an equiangular polygon has all angles congruent. A regular polygon is both equilateral and equiangular. So now I have 3 polygons. Polygons are made up of line segments. And I want to classify them as equilateral, sides the same, equiangular, angles the same, or regular, both sides and angles are congruent. The first shape. This appears to be a rectangle. We know that a rectangle has 4 right angles. It does not have to have sides equal, and this clearly does not. So this has equiangular. All angles, are the same. They're all 90. The next shape. All sides appear to be congruent. A polygon, a quadrilateral that has 4 sides congruent is called a rhombus. And when we have sides congruent, that is called equilateral. It is not regular because this angle here is acute, but this angle over here is obtuse. They are clearly not equal. The next shape. This has 7 sides. 3, 4, 5, 6, 7, and they're all congruent. The angles are all congruent also. When we have angles and sides congruent, it is called regular. By the way, this is a 7-sided figure, and this is called a regular heptagon. To be specific, this was called a rhombus, and this was a rectangle. We also need to know all the names, so you're going to have to get these memorized. I know you know a triangle has 3 sides and a quadrilateral has 4. The 5-sided figure is called a pentagon. A 6-sided figure is called a hexagon. I told you a 7-sided figure on the last page was a heptagon, but sometimes students in the United States do use septagon. Heptagon is the most common, though. And then the 8-sided figure is an octagon. That's a stop sign. And a 9-sided figure, nonagon. 10 is decagon. 11 is elevengon. And then 12 is dodecagon. When we get higher than a 12-sided figure, we tend to do like we did on 11. We'll say a 13gon, 14gon, 15gon. That's how I'll do it. I think they do have some special names, though, but we're not going to use those. By the way, the ones in red that I left here, these are the ones that get mixed up, I guess, on the OGT a lot. So I want to make sure you know those 3. The last page we're going to do today is talking about convex and concave. When we have a convex polygon, all the diagonals lie in the interior of a polygon. A diagonal is when I can take from one vertex and draw to another one a line inside. They're dotted here. This is convex. Okay? What I'm saying is all the diagonals drawn are inside here. Another way that Miss Dever says is that if you can put a rubber band around this shape and it touches every segment, you've got a convex polygon. Concave, however, is if any part of a diagonal lies outside the region. See how this region here, the diagonal's on the outside from vertex to vertex. This is called concave. Punched in, boom. Okay? Again, if I put a rubber band around this shape, this part would not touch the sides of these two segments. So let's get these names down. This one, this purple figure here, happens to be concave, punched in. This one, oh my, a lot of concaveness here, concave. And the last one, convex. I could put a rubber band around this, it would touch every segment, convex. Thank you.